Hi, I'm ZK from ZKCross. We are working on a rollup framework based on ZkEVM. We built this rollup framework particularly for the applications, so it's kind of applications specific rollup. And the design is totally modular. We take a modular approach, so which means that developers can choose any components like the settlement layer, the data availability layer, and also even like the sequencer, we are able to provide the code for the developers to, if they choose to run the sequencer by themselves.
Yeah, good morning, everyone. So, Yaogqi here, founder of AltLayer. So, at AltLayer, we're building sort of various rollup services. So, one thing that we are providing sort of rollups for all different applications like games, social, and also different applications using different tech stacks like OP stack, Arbitrum Orbit, and also Polygon CDK, ZkSync. And beyond that, we are also providing some advanced features together with EthDenver we call real-estate rollups, basically leveraging shared security of Ethereum to provide decentralized verification, fast finality, and sequencing. Yeah.
Hello, I'm Danilo from Kakarot, and Kakarot is basically an EVM written in Cairo, which allows us to prove the EVM execution. And as of now, our first product is an L2 ZkEVM that will settle on Ethereum. So we can say we are an L2 ZK rollup.
Okay, thank you. And for today's panel, we'll have mainly two parts of questions. First is the open questions for every panelist to answer, and the second part, I will spice things up a little bit, like we have targeted questions for each panelist. And then for open questions first, because it's a Appchains panel, so I would love to ask everyone what's the biggest advantage and disadvantages of long-chain and Appchains versus the smart contract. Yeah, we can change the order. Everyone, if want to answer first, can go first.
I think that the biggest advantage right now is you will get cheaper fees and faster transactions. So basically, if a blockchain has a max TPS of, let's say, 100 TPS, but this 100 TPS is usually distributed through many dApps. Like you will not have one dApp taking all the 100 TPS, or they will pay a lot of gas. If you're an app chain, you can take the block space. So basically, having more TPS and cheaper transactions unlocks more applications to be able to be built on the blockchain. I guess the trade-off is very simple. You start fragmenting liquidity. You start one of the interesting parts of blockchain, if not one of the most important ones, is that when you deploy a dApp, your dApp is interoperable with all the other applications on Ethereum naturally. And when you are a dApp chain, you lose that interoperability as of now. So I think that's the biggest difference. So it's basically when you're an app chain, you are a project with your own server using the blockchain technology as an architecture. I would say that's the...
Yeah, so the biggest difference, basically, I think still around is the composability on L1. As we just mentioned, right, for smart contract, natively you can enjoy all the liquidity and also the composability of the existing DeFi protocols on Ethereum. For example, all different LSTs, STEs, REs, and beyond that also the MakerDAO, right, the DAI, and also Uniswap, all the DeFi protocols natively. But on the other hand, for a lot of projects we are talking to, right, especially gaming companies, they're trying to move from this Web2 industry to Web3. And for them, the liquidity on the L1 not be the biggest issue. For them, the biggest issue is still on the throughput and also latency and also the cost. They couldn't really tolerate, for example, 1 second block time. Some of them just directly ask, can we have 100 milliseconds with zero gas, and at the same time, can you launch as many rollups when we scale with more users? So these special demands and requests basically from a lot of the customers we are talking to. And for them, we basically believe that still rollups like dedicated rollups for them are the best approach. Beyond the game, right, and also a bunch of social applications we are talking to, they also want the similar functionality. So basically, they treat the throughput and also fees over the sort of liquidity and also composability. So in that case, we believe that rollup definitely are the sort of go-to solution for them. And also for DeFi protocol, right? Not every DeFi protocol need the liquidity or this composability on Ethereum. For some ones like this perp, we all know this DYDX and Avail, right? So they just need a vault and deposit withdraw basically on the L1. But after that, everything matters for them is really about the performance, whether they can handle all the transactions on the dedicated L2 or on their own chain to basically in a very fast manner. So as you can see, right, it really depends on the scenarios. If you really want to enjoy the existing liquidity and also all the DeFi protocols on Ethereum, better just use smart contracts. But if you really want to have throughput and also based on the lower gas fees, probably the rollups are definitely the better solutions. Yeah.
So both of them, addressed a lot of the advantages of the rollup. So I want to add some from the applications chain's point of view. Beyond the advantage we got from the rollup, now we are taking a level up. So trying to abstract more for the developers. So that's where applications rollup come into play. With this applications specific rollup, we can provide developers more convenience. So they don't need to focus too much or pay attention too much about the rollup itself. So what they need to do is they can focus on the applications itself. They need to know how to create some innovations with their applications, how to write their applications logic based on the rollup underneath. So that's the biggest advantage we want to bring as a project working on the applications rollup side.
So I think the biggest advantage of, let's say, having app-specific rollups at the moment is the fact that if we're looking kind of at the application developer space, we are all kind of like in the EVM space fighting over the same 23,000 developers, and the pie is not growing anymore, right? We need something like AltVMs, like Wasm or RISC-V and similar kind of things to actually go out and, let's say, attract more typical developers in this particular case. Because now we can, and there's not a huge disadvantage to it anymore. Of course, there's disadvantage about composability, about liquidity, and those kind of things. But I think that we are at a point in the industry where we don't have any excuses anymore, because data availability gives us 30 megabytes per second, data availability, plenty of block space, low latency of confirmations, and so on. And we don't have any excuses for not having more developers in the space anymore.
Okay. Not surprisingly, most people mention more about the advantages. Are there any panelists want to add more about the disadvantages and the biggest obstacles for Appchains now?
As I mentioned, right, right now the sort of the shortcoming is still around this composability, all this fragmented liquidity, especially. The bunch of DeFi applications, when we talk to them, their major concerns still around if we deploy on the rollup, right? If they have their dedicated rollup, but at the same time they already deploy multiple L1s and some general purpose L2s. So how they sort of unify or basically aggregate all the liquidity across different chains is a big problem. But luckily, I think a lot of projects are sort of working on that kind of a direction. For example, as Austin mentioned, Appchains trying to figure out ways to basically have this aggregated liquidity. Meanwhile, some of their DeFi projects, like this Kakarot, they're trying to provide this liquidity immediately on all the spin-off OV chains. Same thing applied to Optimism. the superchain vision, right? And also this Polygon CDK's LX, LY bridge. So at least we want to help the rollups spin off using their tech stack to basically bridge these assets across these different rollups seamlessly. It's at least at design stage, right? It's a good approach. It's just like in the end, how to make it really seamless. For example, insert only to bridge asset and wait for another 20 minutes or something. It definitely a lot of room to make the progress, but so far I think it's still around this fragmented sort of liquidity.
Yeah, because next open question is about fragmentation problem, because like the biggest obstacle is the fragmentation problem. So just curious about panelists' recent view about the most interesting interoperability solutions or proposals you saw recently. I think Yaogqi has mentioned a few, and I don't know if other panelists have other thoughts about that.
Yeah, I think what was mentioned here, the Polygon aggregation layer, it's very, very interesting. When we talk about ZK and blockchain, we always knew that ZK and blockchain were a good match, but we took some time to find the first fit of ZK within blockchain. Like the research with ZK started in 2016, 2017, and only later on, we can do layer 2s. So I think that was the first fit where they found like, ZK can be useful building layer 2s. And I think now the second utility of that ZK can bring to blockchain now is solving this interoperability and composability problem, which will allow like trustless messaging mechanisms. So I feel like aggregation layer is one solution to that, but overall I think we might see like a new wave of top tier ZK applications, which are not just ZkEVMs or ZkVMs, because now I think we are facing a new problem, which is basically cross-chain TPS, cross-chain transaction costs, and cross-chain security, and ZK can solve this problem pretty well. So I'm really excited to see ZK products around this.
ZkCross,
Oh, yeah, so everybody is talking about fragmentation. I would rather to put it in another approach, like look at the bright side of
the fragmentation also.
It's back on. So I mean, fragmentation from the bright side, my take is that we can see a lot of people are trying things differently. So this, I mean, to me, because I have been in the software industry over 15 years, so I know how the innovations comes from. So if people don't try, then we don't have the innovation. We don't have like a new killer applications, right? So I would rather to put the fragmentation from the bright side, that it means that we have more people come in to play, to innovate things we don't have currently. So when we reach certain of the prosperity of the industry, then I think that the fragmentation will be a no problem.
So I see that things like AltLayer and, let's say, economic security and interoperability protocols is probably going to be the answer for, let's say, most, let's say, Appchains out there. Also because in the end of the day, like some things don't need as much security. Like, let's say, I'm starting up by having an Appchain with, let's say, a little bit amount of traffic and so on. I don't need this, need something like, let's say, Ethereum strength, let's say, blockchain security for things. And I think that this will basically change into where we have more like, let's say, almost like network interfaces between these different app chains of various different kind of qualities and so on. Because that I see it moving from more like that. We've been talking about kind of like the Ethereum being the world computer. I think in the end game, this looks more like a world cloud for us.
Okay, thank you. And then the next open question is about like because we have parallel execution panel in the afternoon, so I'm just curious about like from the RAS provider side and also framework side, like what's your opinion about the parallel execution? Yeah, ZkCross.
Well, I'm not in a good position to answer this question, but I will try. So since the rollup is kind of the off blockchain, and there are certain spaces we can do with the parallel execution. That's what we are doing right now. Because of the ZK, it provides the possibility to solve the security issues, the concerns comes up for the parallel execution. So since we are also working on ZkEVM, and we believe that the off-chain solution and also the shared settlement layers and the data availability layers can provide the infrastructure underneath for us to solve the problem. I don't have too much technical insight from the technical details about the question, but I'm very optimistic about the future of the parallel execution.
So I think when we talk about parallel execution, right? If it's sort of like we're trying to optimize the EVM, the issue is like EVM by itself is not like designed for this kind of parallel execution. You couldn't even spin off like multiple threads to execute the transactions. At the same time or in parallel. It's quite similar to JavaScript, the V8 engine. So we spent like a year's time improve the execution part, but still, in the end, JavaScript till now is still like single thread execution way. Definitely we can leverage some mechanism to, for example, to sort of order the transactions before they are executed. For example, if the transactions have no sort of share the states or whatever, we can always execute them in different sort of processes or even threads. And after that, we can aggregate these states, and basically the optimization is on sort of ordering of the transactions. Of course, there are some other ways to just maximize the parallelization of the EVM. But the thing is we did a lot of research by 7 or 8 years ago when I was doing the sort of research fellow on building these state sharding protocols. Because in the end, either for parallel execution or this kind of state sharding. So in the end, it's still about the open research question around how to handle shared states efficiently across multiple CPU cores. So in that case, right, it's just either we have multiple shards to handle different transactions at the same time, and then we leverage some cross-shard communication. Or right now, if we have this VM level, right, the parallel execution is basically we need to make sure there's no conflicts of the states across different, either this virtual machine or we need to make sure this parallelization. So in the end, it's still following the same way of basically the result of the executing all the transaction in sequence. I think that's the biggest challenge. But once we sort of have the solution for the parallelization of the execution, right? If it's still around EVM, there's another issue, for example, we encountered previously is really around how to be compatible with all the existing SDKs, wallets, and all the sort of services around the existing Ethereum and also Solidity. If you change sort of the EVM execution, and sometimes probably these SDKs, or especially the RPC import, all things may change, and then all the community services, they couldn't really provide exactly same result you want. So that's not just for this parallel EVM. It's already existing for different clients of Ethereum. For example, everyone treat Go Ethereum as the golden standard, but at the same time we have Nethermind, all the other ones. The interface for RPC are very different. When we build these L2s or different services, we can always see, even sometimes we want to get the hash of the latest block, right? They always return different formats. So this is just one example. One is on the execution or the performance side, right? The other is really about the compatibility with all the existing tools and SDKs. Yeah.
So, well, I think when it comes to kind of like parallel VMs and so on, one of the benefits of AltVM is it doesn't need to see things on a transaction level. It can see a whole block as it comes in, right? And I think that the benefit of AltVM is we can actually expose these abilities to spin out, let's say, parallel virtual machines executing the transactions, leaving it up to the application developer on how best to execute the incoming workload of transactions. And this is, of course, extremely important also in ZK because the more recursiveness, the more execution you do in parallel, the better. So I think it will move closer to that, basically these primitives, just like we're threading and kind of like forking and kind of things like that inside, let's say, Linux at the moment. This will move to this is the application decides how can it best process this and do it the most cost effective.
Yeah, I think besides all the technical benefits, with parallel execution, I think it's very good for Web3 in terms of decentralization. It's very aligned with our ethos, especially let's say with type 1 ZkEVMs, we would be able to allow thousands, if not millions of people to participate on the nodes through verifying Ethereum execution. But there's still the bottleneck, they cannot participate with executing transactions because it would still need like the buffer machine. With parallelization, then we solve this issue where you can now, a lot more people can participate verifying and submitting like an executing transaction. So I think for decentralization, this is very exciting.
Okay, thank you. And then I think that's all for the open questions. Then next part is about more targeted and more spicy questions. So first up is questions for AltLayer. So like say if you have a customer coming up and then you support Polygon CDK, Optimism, Arbitrum, like how would you give suggestions to them to choose which framework?
Oh, it's a really nice question. So the thing is like for most of the customers when we talk to, right, when they reach out to us, they already have their own choice, I would say, because like for a lot of the virtual projects, they already know what kind of ecosystem they want to stay in. So in that case, for most of the mature projects, we just follow their choice and provide the corresponding stack. I think it's just one thing they may ask us to help them to decide is on the DA side, because right now, as we all know, right, probably one, and I think after this proto demonstrating, this cost with blocks will be much cheaper. But the thing is, so far for a lot of these projects, especially game and social projects, they don't really want to use Ethereum as DA. So what they can choose basically Celestia, Identity, and Avail. So that's a part like typically we can help them to show the pros and cons for different. So that's why we always push our partners like Avail to do midnight as soon as possible. Yeah, otherwise even some of the projects they want to launch midnight, they still need to wait for DA to be ready. And I think like first the Web2 companies when they reach out to us, right? I think the biggest difference across different stack. One is especially between the optimistic roller stack and the ZK stack is on the cost. Because for ZK roller stack, right, either you use Polygon CDK or ZK Sync, ZK stack, because you have to run the ZK prover, so the cost is much higher than the typically the running the nodes for optimistic rollup. And so that for some of the projects, that's the sort of the deal breaker. They really prefer, at least at the beginning, they prefer a much lower cost on running these nodes for the rollup stack. On the other hand, we probably see a very interesting sort of observation that for most of the time it's a non-technical decision. Basically, for the project, right? For some of the project, they are influenced by the different rollup ecosystem, DD or the co-founder a lot. Like for example, if it's like for example the Arbitrum AJ talk to project, and then the project probably will just choose Orbit. And if it's Polygon Sandeep talk to project, and probably the project will just use Polygon CDK. And we saw a lot of these examples. So that's why I feel like till now, either for OpenStack or Arbitrum Orbit and also Polygon CDK, right, they are becoming very mature. So the non-technical decisions are really, really important for this project to make the decision.
Yeah, I like that specific. Yeah, and also like the second question is for Cartesi and ZkCross. Like, what do you think is your biggest advantage of your tech stack compared to other frameworks? And also, could you give us more details?
Yeah, so I think that the biggest advantage of the Cartesi framework is the fact that it's not really that distant from the mental model of, let's say, how computers work today, as in it is something where if I, let's say, want to do something completely crazy like having a network interface between two VMs, I can actually do it. I can write with normal languages, I can write with using the existing tools I can boot up the same image in a separate RISC-V emulator if I want to, and kind of like debug it this way. And I think that because it's a standardized set, it's not something we're kind of like, it's a standardized instruction set, not something we need to reinvent all over again. This tooling is already available. And I think that it just makes it so much easier as we're scaling up with this modular stuff to just basically arrive to this is the right way of doing things, right? In how kind of like you design things, how you prototype things, and so on. So that's what I see kind of like as a key advantage.
So speaking of the advantages, I mean, we both are working on the general purpose ZK virtual machine. And we can benefit a lot, especially for us, because we leverage Wasm's WebAssemblies ecosystem. So we got a lot of leverages from there, like the developers, the programming languages, the tooling, and also other, like even the deployment platform. We can benefit from there. But beyond that, combine the Web 2, the WebAssembly, and the Web 3. So we now working on something probably very interesting to developers. We now are working on to make the applications totally stateful. That are also, well, we made some progress, and now we can support developers to develop like a multiplayer game. So which means it's very much similar to the to the game in the Web 2 industry, like the game users can play together, and then they can share the status. The status can be updated through us, and then we can store the data, synchronize the state to the data availability, which means they can also take a benefit from the Web 3, which is very viable, and also they can enjoy the existing game experience from Web 2. So that's the thing we are working on. I think that this is a very big advantage. I didn't see any other projects are working on this, but we are providing this. We are making small progress with it. So in maybe a month or two, so we will make it public, and developers can write some multiple players game with us.
Okay, so will AltLayer envision Cartesi and ZkCross as competitor or complementary to your tech stack?
I mean, for us?
Yes.
We welcome all the different VMs to support all of them. Yeah. like the WASM. Because our side, right, previously we also built something natively in Rust and WASM. So it's just like our side, typically for the past few years, we really accumulate a lot of experience on dealing with different clients and customers from different industries, from gaming, the gaming studios, very big IPs, and also some producers with very good games, also some fully on-chain game projects, social, traditional social, crypto native social, DeFi, like KYC based DeFi, or even like the kind of normal crypto native DeFi. So right now, it's our experience that we really treat the demands and requests from the partners and clients in a like sort of very important way. Because like a few years ago, we were building some public blockchains, but in the end, for the past few years, we found out there's a huge gap between what the real clients want and also what we researchers were doing. Basically, for one example, like for the, as I mentioned, like for the big gaming company, they want this sub-second latency and also zero gas, plus like sort of super low gas fee. I mean, high throughput, and also deploy rollups in multiple regions. So these things are completely different from, like, for example, when we're discussing the all the decent like benefits or advantages of ZK rollup, all the things. But in the end, the deal breaker for these clients are still around like sort of the latency and throughput. It's not really about like what kind of security guarantee we can provide for them. And then there another example, like recently we all know like risk-taking AltLayer, they are also our close partner. A lot of projects want to have some of the risk-taking features. So that's why we together with AltLayer built this risk-taking rollup for faster finality and also the share like decentralized verification. These are really like the partners or clients want us to provide. So the good thing, like once they have that kind of request, at least we have the real use cases. Once we develop that kind of services, we will use it. And back to the point, right, you mentioned like for different VMs. It's just like I believe, especially for WASM, a lot of these Web2 projects, they prefer use their own sort of programming language instead of Solidity. So in that case, I believe like a WASM-based VM, or at least you can support multiple programming language, has a much much better advantage compared to pure Solidity. And also sometimes like when we talk to project, right, they want the ZK proof. So that's why we also work with RISC-0. RISC-0, you know, is sort of based on RISC-V instruction. Like normally no one writing RISC-V kind of program, but due to like they can really quickly generate ZK proof, and then some of the partners and clients want to use them. So I would say like there's just so many, clients and applications who want to adopt rollups. And I believe we can't say one rollup stack can basically provide all the functionalities or feature for them. It's just like really based on their sort of requests, we need to customize either on the VM side or on the feature side just to make sure it's really sort of useful.
Thank you. And the next question is for Kakarot. Like, you're building a provable EVM return with Kakarot, but like, why an Appchain route? Like, why not just choose like non-EVM options like ZkCross?
So when we started writing the EVM in Cairo, it started as a fun project actually. Like we weren't planning like, oh, we're gonna become an L2. Like it's like we can write like Cairo is provable. We can write the EVM in Cairo. Let's try it out and see what happens. And because of the properties of Cairo like is both like you can both execute it off chain and just generate traces that will generate Stark proofs with it, or you can use it as a smart contract on Starknet. So when we started, we had like, oh, we have many routes we can go. We can deploy on Starknet and now allow any EVM applications to also deploy on Starknet. Or we can just use the Starknet stack or Madara or any Starknet node and have our own L2. Last year we decided to go as our own L2 because still there are some overheads. We're writing an EVM on top of a VM, so there's definitely some overheads compared to Kakarot. But that's the reason why we ended up going as an app chain, because it made more sense of what we could deliver. Like we believe that being an L2 will be more useful for users than just being a smart contract on Kakarot. And why we chose a ZkEVM compared to ZkEVM is basically we wanted to tap into the already existing ecosystem. So we're very aligned with the Ethereum ethos. We want to scale Ethereum, and we are from the Starknet ecosystem, and there we felt the pain of how it is to be in an ecosystem where there is no tooling, very few devs. You know the developer of all the other all the libraries, you know them in person because there's so little people. They talk about bugs every day. Like this was in the very beginning. Now it's a little bit less. So we feel the pain of and how it takes time for an ecosystem to mature. And Ethereum is very, very mature. So we thought we have this amazing tech from Starkware. We have this amazing community from the Ethereum. Then I think we have the best of the two worlds. So that's why we ended up going the EVM route than just choosing and doing another ZkEVM.
Does ZkCross want to respond?
Well, I think that the whole industry is still small. It's not a winner takes all. So from us, we would like to work something from a small part to contribute to the industry. Like I just mentioned, we're now working on the fully stateful ZK provable applications framework, which means that developers can use not only leverage the security or the others from the settlement layer, but also they can leverage the benefit from traditional IT industry. And also we want to let the developers to benefit from their existing skill set. That's also the small part we are working on. We want developers to use their existing skill set to develop a real no matter it's web browsers based application or mobile phone based applications. In the meantime, they can benefit from ZK and also use blockchain. So that's why we are here.
Okay, then final question is for Cartesi. What's your opinion about the comparison between optimistic rollout and ZK rollout? And will Cartesi shift to ZK in the future too?
So the benefit of being a RISC-V virtual machine is that we don't really need to choose between, let's say, optimistic and ZK. We have been running Linux inside ZK. It takes a while, it's not the most performant in the world. But there's no reason why you can't do that. Of course, we have optimistic proving this particular case, but in the end of the day, these two things are just about when you, let's say, want to prove something to another chain, right? And if we're looking at, for example, let's say, share sequencing and things like Espresso and so on, it's much more about the performance of which you can go ahead and, let's say, run an execution inside, for example, a block builder and following along with the chain and so on. The actual the proving part is actually, let's say, much less when you actually want to settle into a layer 1. And a lot of the traffic is not going to be let's say, layer 2 to layer 1, it's going to be layer 2 to layer 2 instead. So it really comes down to what's the use case? We have the benefit because we have a general purpose virtual machine that we can run some parts in public, some parts in, let's say, in secret, let's say basically encrypting the RAM for a little while, going back into, let's say, public after we're finished and get it out to result, and nobody ever know what happened in between those two execution points. So this is why I absolutely love that there's projects for example, RISC-0, where we quite easily can go in and plug in existing infrastructure written in C, C++, Rust, and so on, and combine it with something like our technology. And because it's RISC-V, we can actually hardware accelerate what we're doing if we really need to. We can even throw things into a GPU if we want to. it just comes down to when do you need to prove it to somebody else, and this is also where, let's say, cryptoeconomic security of some of these interoperability protocols will actually matter a lot more.
Okay, thank you. And that's all for this panel. Thanks for staying.